Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 26 of the October daily Leetcode challenge, and we have a very good quality question in front of us. Let me tell you this: if you solve this kind of question, I'm definitely sure that you will be feeling the kind of proudness in you that you are able to do it. Okay, after a very long time, we are going to see a question on trees, which is at the level of hard. Okay, and let me tell you this: once you solve it, you will be really proud that you are able to do this because remember there is no such rocket science needed to solve this kind of questions. Just some observations and just being good at what the simple basics are for trees. Okay, if you are very good in the basics of trees, and if you can analyze this particular scenario, I'm damn sure you will be able to come up to this kind of solutions. Okay, so let us see what the question is. So height of binary tree after subtree removal queries. Okay, so what is happening is a binary tree is given to us. Okay, that is the basic thing, and we'll have to remove a subtree. After remove the subtree, we'll have to predict what is the height of the tree which is remaining. Okay, we'll see the exact question now. Okay, you are given the root of a binary tree with n nodes. Okay, each node is assigned a unique value 1 to 1. Okay, remember the value on the nodes are unique. That is also one important part in this question because the solution will be using this particular property. Okay, all the nodes have unique values. Okay, none of the values are repeating. You are also given an array. That is the queries that if you see the one example, this is all the things which are given to us. Okay, the root of a binary tree and the query is given to us. And if you're new to the lead code, let me tell you this: the way you're seeing this is not how it is being given in the input. Okay, this is just for a simple appearance. It is shown as an array, but in reality, will be given the root of a tree. Okay, when I say root of a tree, it basically each node in the tree will have this particular structure. I hope you're knowing this, but if you're new, just wanted to make you aware of this. Okay, so what is happening? You have to perform m independent queries on the tree where ith query you do ith query will do the following. Okay, remove the subtree rooted at the node with the value of query survive from the tree. It is guaranteed that query survive will not be equal to the value of the root. That is, the root will never be removed. Okay, return an array of answer of size m where answer of is the height of the tree after performing the ith query. Okay, so basically what they're trying to say is, let us say the left whatever you're seeing is the original root. Okay, original tree. What you have to do, you have to remove the node which has a value 4. Okay, that is this node you have to remove in the value 4. Like this, in currently there is only one element in the queries array. There can be many, but what you have to do is for each such queries, okay, you will have to tell me after I remove the that particular node. Okay, what will be the value of the remaining tree? Okay, that is after removing that particular subtree, so a tree will be remaining, right? We'll have to guess the height of that particular tree. Okay, that is the question here. So in this case, after removing the fourth node, at the node with the value 4, what is going to height of the thing? In this case it is 3. Sorry, in this case it is 2. You'll have to add the 2 here. Okay, so we'll understand that what is the definition of height and all those things we'll understand, but just wanted to show you what it is exactly. Okay, so queries are independent, so the tree is returned to its initial state after each query. Okay, that is just for that query you have to remove that part of the subtree. For the next query you should be okay, originally considering the tree as it is. Okay, that is the basic idea. The height of a tree is the number of edges in the longest simple path from root to some node in the tree. Okay, so as you can see, there are once if you have to travel from 1 to 2, you will be passing over 2 edges. That's why 2 is the answer here. Okay, yeah, after removing the node with value 4, this is the tree present. Okay, here to reach from the root to the leaf, we'll have to travel 2 edges, so answer is 2. And same is the case here. If you see, there are multiple queries present here. Like this, in the original selection answer, this will be given. What we'll have to do in the output, basically you'll have to tell me after that particular node is removed, that is the node with the value 3 is removed here, you'll have to tell me for the remaining subtree what is going to be the height, and you have to return that. Okay, so this is the original question, and these are some of the constraints. This is the most important part here. Okay, that the values are going to be unique. Okay, and yeah, rest of the things you can go through that. Okay, but let us see what we can do here. Okay, so my solution is going to be very simple. Let's see, I'm not going to use any generic approach as such here. I will be modifying the approach that are generic, and for this approach I will for this question I will be getting a solution. So though I have named this particular array as in order, it will not be exactly in order. I will tell you why. See, what happens is, what I'm doing, I am processing the current node. Okay, then I'm processing the left subtree, and then I'm processing the right subtree, and again when I'm coming back to original node, again I'm processing that. So it is not a in order, pre order, or post order, anything as such, but a modified version of all of them. Okay, so basically I'm just for convenience I'm calling it as in order. You can call it anything, it is not exactly in order, by the way. Okay, let me make it very clear. Okay, so that you don't have any doubts in the comments below. Okay, you don't have to post this out in the comments. This is not exactly in order, just for a reference I'm calling it. My initial plans were different, but yeah, the solution that I developed, I'm keeping it as it is for now, but it is not exactly in order. Okay, By the way, it is nothing like in order, pre-order, post-order. It's not much any of them. It's actually a modified version of all of them. Okay. Because see, first I'm taking the original root, I'm processing it, then the left subtree, then the right subtree, and again I'm coming back to the root and processing it. Okay. So it is matching, not matching any of the in order, pre-order, or post-order. Okay. By the way, all these are traversals. They are part of the DFS. Okay. So that's why I've renamed the function as DFS. So this is basically a function. Okay. And this is the function call. Okay. I will show you how this in order looks. So what I'm doing is, see, I'm declaring L. What is L going to be? It's going to be the depth. Okay. It is going to be the depth. The root is at the depth of 0. And similarly, when you moved on by one layer, the depth will increase by 1 for each. Okay. So what I'm doing here, if root is none, simply return none. Okay. That's the basic step. That is the base condition to stop this recursion. Okay. What is next? So what I'm going to append, that is in this array, what I'm going to append is that append a tuple. What is a tuple? Basically, you have to append two values. Okay. That is the current value of the node. Okay. That is 1 in this case, and it's L. Okay. L is the depth. Okay. What L is the depth. Append it like this for the root. Similarly, call this DFS function for the left subtree, but make ls L plus 1. Okay. Because I'm going one, layer below. So you have to make ls L plus 1. Okay. Same thing you have to do for right subtree. Call DFS. Let it once you return after processing the left subtree. Once you come back here, process the right subtree, that is start the defense function with the root dot right. Okay. And pass ls L plus 1. Okay. Once the two left subtrees are processed, remember it's a binary, so only two childs will be there. Okay. Once the two childs are processed, what I have to do, again process the current node. Okay. So what I'm doing in the in order array, that is the in order array, what I'm doing, I am including another tuple which is same. Okay. Whatever is here, the same thing here. Okay. So I'm appending the same value again. Why I'm doing this, I will tell you why in a second. But yeah, this is the function call of it, and this is the in order array. Okay. I am printing it. So let me quickly run this part and show you how it looks. After that, you will get to know why actually I'm doing this. Okay. Let me explain that. Yeah. So this is going to be my in order array. Okay. So if you see here, first I am at 1, which is at the root of at the depth of 0. Then I'm coming to 3. Okay. Which is at a depth of 1. Okay. Then I'm coming to 2, which is at the depth of 2. Okay. There are no subtleties for 2, so again I'm coming back to 2, which is again at a depth of 2. Depth will remain same. Okay. Then I'm coming back to 3. 3 again, see, 3 I've already processed. I'm coming back to 3 again. Okay. Then I'm again going to the right part of the 1. Okay. The right subtree of 1, which is I'm coming back to 1, that is 4, which is at a depth 1, and so on. Okay. Then I'm going to 6, which is at the depth 2, and so on. Then I will be going at 7 also, which is at depth 3, and so on. Okay. So this is my inner array. So like how it is going to help me in getting the solution. See, the idea is very, very simple. See, the way it is defined. Okay. For example, let us say in this question, what they are asking, if I remove, okay, okay, let me talk about this thing. Okay. The If you scroll, zoom here, this 3 node. Okay. The node with the value 3. Okay. It has a depth of 1. Okay. Let us discuss, if I remove 3, what is going to be the height of the subtree. So in this, what you have to see, first of all, look at where 3 is coming. Okay. This is where 3 is coming first time, and this is where 3 is coming second time. Okay. These are the ones. Okay. This is where 3 is coming for the first time, this is where 3 is coming for the second time. Okay. So what you have to do, see, before coming to 3, that is when the first time 3 is appearing, scan all the elements to its left. Okay. This is the first time 3 is appearing, so scan all the elements towards its left. Okay. This is the only element present in the its left, and take its depth. Okay. Take the maximum depth among all the elements present to its left. See, 3 is appearing here for the first time. Among all the elements towards its left, take the maximum depth. Okay. In this case, 0 is the depth. Okay. So this could be one of the possible answers. Okay. This is the first time 3 is appearing. Next, go to 3, where the 3 is appearing for the second time, that is here. Okay. All the elements towards its right, take the maximum depth. Okay. These are all the elements which are towards its right. Among them, take the maximum depth. In this case, the maximum depth is going to be 3. Okay. So 3 is again another answer. So among 0 and 3, okay, among 0 and 3, 3 is bigger. That's why if you remove the subtree of value 3, the answer is going to be 3 again. Okay. That is what we are going to do. Okay. Because see, if you remove this 3, if you remove this node with value 3, we'll see that 1, 4, 5, and 7 are still there, and that is going to form a tree of a depth 3. Okay. That is what you have to return. Okay. A tree of height 3 is they are forming, so you have to return answer as 3. So that is what I'm going to, I hope you understand my approach. So what you have to do, see, for whichever element you are required to find. For example, in this case, they are asking for 4. Okay. So let us do it for 4 ones. Okay. So here 4 is present, right? So this is the first time where 4 is present, and this is the second time where 4 is present. Okay. So what you have to do, wherever 4 is coming for the first time. Okay. So towards its left, scan all the elements and find the maximum depth among them. Okay. So these are the elements I have to scan, and I have to find the maximum depth among them. So in this, if you see the depth, I'm saying, I'm not saying the numbers. Okay. I'm saying the depth. So it is 0, 1, 2, 2, and 1. So maximum depth among its left is 2. Okay. Now look at where 4 is coming again and scan all the elements what is right. Okay, this is the only one coming and the data is 0 here. So among them, 2 is having the maximum depth. Okay, so the answer is in this case is 2. I hope you're understanding what I'm saying. Please pause this video once again, go back to last 1 minute, last 30 or 40 seconds, and I'm damn sure if you revive, see that again and again, you'll get to know what I'm saying. The traversal that we have done is helping us get the answer. Okay, see, the idea here is before I came to 3, what are the nodes that I visited, what were the depths. Okay, similarly after I came out of 3, okay, after pressing the left and right subtree of 3, what are the nodes that I visited, among them what is the maximum height. Okay, among these two, that is before visiting 3 and after visiting 3. Okay, before coming to 3 and after pressing all subtrees of 3 and the node itself, what are the maximum height that I'm going to visit. That is going to be my answer. Okay, so what I'm going to do, I'm now going to declare two arrays. Okay, because see, this involves a lot of, like, I have to scan all the elements towards left and again scan all the elements towards its right and find the depth. So for easing that purpose, what I'm going to do, I'm going to declare two arrays again. Okay, what is that? Maximum left towards its left, maximum depth towards the right. Okay, I'm going to declare these two arrays. So what I'm going to do, for each element I need to find what is the maximum depth towards its left, and similarly for each element I need to find what is the maximum depth towards its right. Okay, so if you see here, for, yeah, for 3, what is the maximum depth towards the left? It is going to be 0. Okay, so it's 3 is at a position of this. Okay, so same position I go to this array. See, this is the one of that arrays. Okay, maximum depth towards the left. Okay, this is the array for that. Okay, 3 is at second position, I'm going to second position and it's showing 0. That means the maximum depth possible before 3 is 0, because this is 0. Okay, similarly, let's see where 3 is coming again second time here. So the maximum depth after 3, okay, that is maximum depth among all this is going to be shown by this array. Okay, is going to show by this array. So at which position 3 is present? If you see 1, 2, 3, 4, and 5, this particular thing is coming in the 5th position. So go to the 5th position of this particular array. Okay, here you will see 3. That is the maximum depth possible after I go out of 3 is 3. Okay, so that is why this array is helping me in getting that. Okay, so I'm doing that. Yeah, this is the part here. Okay, for value comma depth in order. Okay, what you have to do, max depth from left dot append max. Okay, initial max is 0, I'll have to append 0 as it is first. Okay, then do the processing. Okay, max is equal to max of the previous max comma the current depth. Okay, the current depth. So this is the processing for max element, max depth from left. Okay, same thing I have to do for max depth from right. Okay, you can do it anyway. I am, what I'm doing, I am, scanning the area in the reverse, and then again I'm doing the reverse. Okay, I'm again doing the reverse here. Okay, you can do any way you want, but I have told you the logic what I'm doing here. Okay, same thing I'm going through, appending the values here. Okay, and then I'm again calculating the max. Okay, at last I'm reversing this array because I want the elements from left. Okay, that is the maximum elements towards its right. Okay, maximum depth towards its right. That's why I'm doing this here. Okay, let me again show you this how it looks. So if you can tell me, okay, let us take the case of 4. Okay, let us take the case of 4. So can you tell me quickly what is going to be the maximum depth towards the left of 4? Okay, can you quickly tell me? Okay, pause the video and quickly tell me. So this particular element is present here. Okay, right, this is the element here. So maximum depth towards the left is going to be 2. And similarly, if you have to tell me what is the maximum depth towards its right, okay, what is that going to be? So you have, the answer here is 0. So okay, among 0 and among 2, what is the maximum value? 2. So 2 is going to be the answer when the subtree with value 4 is removed. Okay, subtree starting from node 4 is removed. Yeah, so that is how I'm going to doing it. Okay, so I'm printing these things for your reference. Then I'm going to find the answer for each node. See, I'm going to find the answer for each node and save it in answer, so that whenever a query comes, I can return the answer from my cached memory. Okay, as simple as that. So what I'm doing, start I is going to be every node in the in order traversal that we already did. Okay, what I'm going to do, if in order of I is not present initially, that is I'm visiting a node for the first time. Okay, in order I of 0. What is in order of I of 0? Basically, it is going to be the node value. Okay, these are going to be the node values. Okay, these are the node values, and the second value is the depth. Okay, second value of them is the depth. Okay, so in the tuple. So in the tuple, the first value, that is the 0th value I'm going to take. Okay, that is, this condition basically means that if I'm visiting a node for the first time, okay, what I have to do, cache the maximum value from left for that. Okay, cache maximum value from left. Okay, for that. Okay, that is for that particular value. Okay, for that particular value, cache the maximum depth from left. Okay, now when this condition will be true, when we are visiting that element for the second time, that is, for example, see, after pressing all the left and right subtricks of that, when we are coming to the node for the second time, that is here. Okay, so this is the where we are visiting the node for the first time, and this is where we are visiting the node for the second time. Okay, that is what it is. Okay, so when we are visiting the node for the second time, this time what we have to do, this time we have to compare the existing value of answer and the maximum depth from right. Okay, maximum depth from right. Initial what we did, maximum depth from left. Okay, that is stored here. Okay, this particular thing. Now what we have to do, compare the same thing here, compare the same thing here, but this time we have to compare it with maximum depth from right. Okay, that is the second time it is appearing, and again you have to store the maximum of both the things in this thing. Okay, so my answer will now have, for each node I've answer now. Okay, so whenever that subtree is removed, I know what is the answer. So what you have to remove, ultimately scan all the queries, and that is for I in each of the, that is I am going through each of the elements of the queries array, that is this particular array. Okay, queries array, and I'm calling them as I. Okay, I am returning answer of I in the solution, and I'm writing this as a list. Okay, then that is all. So if I can run this and show you. Yeah, if you see, all the test cases are getting cleared, I'm already submitted the solution and it is accepted. As you can see here, I've already solved this solution. Okay. Yeah. So this is the maximum, depth from left, and this is the maximum depth from right. Okay. We need, see, whenever we are visiting the element for the first time, for example, this thing, I visited two for the first time, so I need to know the depth, maximum depth towards the left. Okay. This is also important. Similarly, when I, visiting the element for the second time, that is this, that is, yeah, I need to know all the maximum depth towards its right. Okay. Yeah, this part. So for to get those things, I have made this array. Okay, for example, here 2 is the third element, so get the depth here, that is maximum depth is 1 in this case. Okay, if you see the here, once I remove 2, before wasting 2, the maximum that I saw is 1. Okay, similarly when 2 is coming again, 2 is coming again at the fourth place. Okay, 0 1 2 3 4 here. So the maximum depth towards the right is going to be 3, because if you see, if I remove 2, still the 7 is there, right? 7 will be contributing for the height now. Okay, so maximum height is 6. So among these two, okay, that is among 1 and among 3, which is maximum, obviously 3 is maximum. So the idea is when the node 2 is removed, the height of the subtree is going to remain 3, and that I am returning. Okay, that is the basic thing. And yeah, okay, if you want, I can even show that to you. Okay, let me just show it. So yeah, this 4, right, I am including 2 here, and you will get to see that the answer is 3 for this. Yeah. So you see here, yeah, the second answer is 3. Okay, and that is also the expected answer here. Okay, that is the expected answer here. So yeah, fun. That was all for this video. So what we did here, basically we modified one of the traversals that we already know. Okay, though it is not directly in order, we modified it to process the way we need, because we are processing the root first, the left subtree, the right subtree, and again we are processing the root. Okay, we are doing that. Okay, then what we did, then basically we are just finding the depths. Okay, before visiting the subtree and after visiting that particular node. Okay, we are finding the depths so that we can make the calculation quicker. See, remember, this is just to make the calculation quicker, though you don't need it directly. Okay, just to make the answer simpler and quicker, we are doing this. Okay, then I'm caching all the values, that is for each node. I'm caching the answer, that is the height of the tree after I remove that node. Okay, the key is the node, the value is the depth of the tree after we remove that node. Okay, that is what is to be stored in my answer. And lastly, what I'm doing, for each query, I'm returning its answer in a list, as simple as that. So yeah, friend, that was all for this video. I know like this will be too heavy if you are seeing this for the first time, but I'm damn sure that if you haven't followed my video, or at least if you haven't following Leetcode, for quite some time now, and if you have all the concepts of trees very, very clear in you, I'm damn sure you will be able to understand this solution. And not only just understand, I'm damn sure you will also find other ways to do the same. Okay, the way I found here, similarly, if you find other ways to do the same, please do let me know, we can compare which is better. This is just idea that I had, and I coded it and showed it to you. Similarly, maybe you can also code and show it to me the way you are doing it, so that we have can learn something from each other, right? So it's all about a journey of learning from each other. I am doing all these things because, see, why, see, you may be knowing coding, but the courage to code every day is not something that comes very easily, right? So I do this kind of videos to show you that, yeah, what knowledge I have, so that I can also build other knowledge. Okay, because I have a reason that I want to show it to you. Same thing you can also do, that will also give you a reason to code every day. So yeah, friend, that was all for today. See you tomorrow. Thanks a lot.